Let me just check your first. You are studying engineering, I guess.
Not exactly engineering, but yeah.
Okay. Can we take? Let me just check your information before I start with my information. Assume that we have this circuit. I will provide a simple circuit right now, and I will just add some lamps. Okay. Do you know what do we call this circuit? Is it a parallel or a series circuit?
This is a parallel circuit.
Great, great. Is there any information about the parallel circuit? What about the voltage, the current across these lamps?
Yeah. Okay, so hold on. It's just my memory isn't quite well.
No problem.
It's either the current is equal through all or the voltage is equal through all.
Well, the voltage is going to be equal.
So the voltage, yeah.
Yeah.
And then for the series, it's the current.
Usually,
The
usually your home is a parallel connection. So all the devices will be working within the same voltage. The laptop, the phone, etc., the lamps, fridge, etc. So this is a parallel circuit.
Okay.
Okay, concerning the current, it might be the same, it might be not. It depends on the lamps itself. If the lamps are identical, they will consume the same current. If not, they will consume different values. But the thing that we are sure about, it's the voltage. The voltage is exactly the same. Okay, let's just check this one. Okay, this is the FET application used by the University, I guess, of Colorado, I guess that. This is a parallel circuit, and this is the voltage source. These are 3 lamps. If we try just to check the voltage across any of these lamps, we will see that the voltage will be the same. It's going to be, we call it the law of uniqueness of voltages in a parallel circuit. Okay, so as you can see here on the voltmeter or the multimeter functioning as a voltmeter, it's 10 volts always and always. Concerning the current, it's not the case. It might be equal. Look here, if we just take a look on the main branch, the current is 3 ampere.
Yeah.
It's 1 for the first lamp, 1 for the second, and 1 for the third. So they are equal. But if we change the characteristics of these lamps, then right now we can see that the current used by the first lamp is different than the current used by the second, since we changed the characteristics or we changed the resistance of this lamp. Is that clear?
Yeah.
Okay, great. Do you know what do we call one of these points? This point, what do we call it? Usually we can say either it's a node,
Yeah, a node.
yes, or
Yeah.
a junction. Later on, we'll use Kirchhoff's voltage and Kirchhoff's current law. We apply the law of currents across a node or a junction, which is the meeting point for more than one branch. Usually, the main difference between a series and a parallel, let's take just directly the series circuit. Okay. We'll take just 2 lamps for the moment. Okay. If we try just to close the circuit, what's your expectations concerning the voltage and the current right now? Do you expect anything? The battery is 10 volts. What will be the voltage across each of these two lamps? The voltage will be equal or the current here in this circuit?
The current would be equal,
Okay, great.
but the voltage,
Is additive. So let's check it
yeah.
out. If we close the circuit and we check First of all, sure, the current will be equal since it's only one loop. So at any point in this loop, the current will be 1 ampere, no difference at all. If you can just take a look on the ammeter. So in a series connection, the current will be the same. Concerning the voltage across the main battery is 10. The voltage, okay, can you see something wrong here? I'm just connecting this one in the wrong way, okay. The voltage across the first lamp will be 5, and across the second lamp, also 5. But this is not the rule. The rule says that if the characteristics of these two lamps are different, then one of the lamps will take some of the voltage, the other lamp will take the remaining value, but the total, the sum of these, yes, that's great. So the sum, that's great. So if we take a summary here for this part, this is a series connection, and so this is V1 and this is V2, and the main voltage is V. So V will be equal to V1 plus V2. While in a parallel circuit, V will be equal to V1 equal V2 equal V3. This is the law of addition. Voltage,
Okay. Yeah.
This is the law of uniqueness. The voltage will be the same. And this is series connection. Okay, any problem with that till now?
No.
Let's move to something else concerning the Ohm's law, and later on we will go deep into the remaining part. First of all, if we, do you know, sorry, do you know why we use, or what's Ohm's law? We use it for what?
Ohm's law is V is equal to R resistance times
Current.
current.
Yes, that's
right?
great. We use it for a lamp or for resistors.
Yeah.
Usually we use Ohm's law, or we apply Ohm's law only for resistors.
Yeah. Resistors.
Yes. Let's check the value of each of these two resistors. Usually we can check the shape of resistors. Okay, let me just draw it here. Okay, in order to study a resistor, we usually take, or to study any component, let's say we have a capacitor, let's say we have a coil. To study any of these components or elements, we need a circuit. In this circuit, we need a variable voltage source, and I will explain what is a variable voltage source. And we need the resistor itself. Let me change the color. Okay, this is the resistor. We can use this symbol for resistors. And we have to add an ammeter. And finally, we must add a voltmeter. Do you have any expectations why we use such a circuit? Usually, voltmeter. In order to study any component, we must use a variable voltage source and check what will happen if we change the voltage. So depending on the results, we can just say this element will work on this formula or on other formulas. Ohm's law is applied as an experimental setup before finding the equation. So the equation, which is U equal Ri or V equal R times I, it's just an experimental setup. The results showed us that we must use this formula. How did they find this? If we take a simple circuit, let's take one resistor for now. Okay. The voltage across this battery is 10 and the resistance is 10. And now we'll close the switch and let's check the voltage across this one. And the other device will check the current. This circuit is totally similar to the circuit that I have shown you seconds before. Okay, the difference, how can they study such a circuit? They will change the voltage. So instead of putting it on 10 volts, they will put it to 11, and then they will check the results. So as you can see, the voltage across the resistor increased from 10 to 11, the current from 1 to 1.1. And then the same, we can just go into 12, and the voltage is just increasing, and the current is just increasing. If we take set of values, and try to show, let me just draw it as a table first, it's better. Okay, so this is U in volts, and this is I in amps. We'll take just set of values. For voltage, let's say from 0, it will be 0. From, let's say 1, 1, 2, 2, etc. I'm just putting random numbers to know how to use the formula. Now, if we draw them on the graph, you have an expectations what will look like the graph for U versus
For the I and V, it would be increasing.
Yes, it will be an increasing straight line.
constantly.
That's great.
Yeah.
So from 0, 0, from 1, 1, 2,
2, 2, 3, 3,
etc.
up
Yes.
to 5, 5. Yeah.
So it will look like this, similar to this one.
Mhm.
Okay, now if we want to check what is the value of the resistance, if
It's
we
so
go,
slow.
yes, so just choose any two values. Let's choose these two values from the table or from the graph. And then you can say, usually the slope, you know the slope, right?
Yeah.
Okay, so if we find the slope here, which is the y over the x, or delta y over delta x, it will give us will provide us, let's say 2 over 2 over, or 4 over 4, and 1 ohm. So this is, if I'm going to write the formula for that, the formula will be R equal U over I. If we take any other values, let's say 1 over 1 or 5 over 5, they will provide us 1 ohms. So the same way we'll divide usually the voltage over the current, okay? And not the opposite. So this is what we call it Ohm's law. It's an experimental setup. Usually the resistance for a simple circuit will not change. So here, if we just check the resistance, which is 10 in this example, it's not going to change. The only elements that are changing the voltage, and as you can see, also the current will be changing across the ammeter. Okay, usually if we want to check, is there any question till now before I move on?
No.
Okay. Assume that we have more than one curve. Okay, all these are straight lines. Although we can say this graph shows the curve of a resistor, but it's a straight line. Always it's going to be a straight line passing through the origin. And we said that each curve represents the resistance. If we take the maximum curve, which is the blue color, the vertical line, and this is the voltage graph, and this is the current graph. Usually, here, if I want to ask you, let's say, assume that each position shows, let's say, 5 volts. So 5, 10, 15, and let's say this value is 20. So here, the value of the voltage is 20 volts. I'm talking about the blue line exactly. But what is the current? Can you tell me what is the current in that case?
If
At any value, just choose, let's say 20 or 15. Usually, if we take any of the other graphs, let's take this one in the middle one. For 5 volts, the current will be, let's say 1.
Yeah.
Is that right?
Yeah.
Okay. So for 5 volts, it's 1. If we take the blue graph, for 5 volts, it's 0. For 10 volts, it's 0. For 15, for 20, no current is passing.
Yeah.
Yeah.
Oh, okay.
So for the blue line, we can say that it's total an insulator. You know the meaning of insulator?
I do. I think I say I don't remember.
The materials that doesn't allow current to flow, like wood, we call these materials insulators or plastic.
Oh yeah. Okay.
Yeah. So here we can say that the resistance will be close to infinity. So there is a high resistance for this material. It doesn't allow current to flow at all, even though if you raise the voltage. Is it clear?
Yeah.
Okay, let's take now the green color. Okay, wait. Okay, let me just choose the green color on the x-axis or on the current axis. Okay, if I ask you what is the value of the voltage here? Can you see?
0.
It's 0 volts, but the current, it's
The
different than
current,
0.
yeah, it keeps increasing.
It's just increasing. Yes, great. So for such a graph, the resistance is approximately 0, or it's 0. This is a total conductor. It allows the flow of current, even though there is no high voltage. Is that clear? So if we want to take a conclusion, as much as we go in this way, the resistance will be decreasing. Okay. Okay, any questions till now?
No.
Great. Okay, let me just move right now to go deep into a little bit for circuits, parallel and series circuit, exactly. I will move into a complicated one. Let me just show here. Can you tell me what's the direction of the current in this case? Is it going to be anti-clockwise or clockwise? To the left or to the right?
It's gonna be to the left.
To the left.
Because the plus sign is on the left.
Yes. Okay, let me just ask you, how can you find the current here in this case?
The current would be what, hold on, V over R, which is 25 over 5.
Great,
We're
great.
gonna get 5.
Okay, so here we just find the current I by dividing the voltage, which is 25, over the value of the ohm, or the resistance, which is 5 ohm. Let me just go into okay, I will just try to explain the main concept of Kirchhoff's voltage law in a circuit. Can you just differentiate, or do you know the difference between Kirchhoff's voltage law and the law of additions of voltages in a series circuit, for example? Do you know the main difference between them, or is it hard?
I don't think it's hard, but I didn't revise actually, so my memory is
Okay,
a bit
no
foggy.
problem.
So
No problem. Okay, usually do you use the symbol V or the symbol U for voltage?
V.
V. Okay, the main difference between the law of addition of voltages and Kirchhoff's voltage law, if we want to apply it here, let me just provide some names. Let's say this is P, this point is N. Let's call this A, and this is B, and this is C. Okay. The law of addition of voltages states that, I'll try to write it here. The law of addition of voltages states that V across the main battery will be equal to V1 plus V2. But we can write it in a different way. We can write like this. V between points P and N, which is the main battery, equals to the sum of the voltages in the whole circuit. So VPA, and then I will move to, I'm just going in this direction from the positive terminal towards the negative terminal. PA plus VAB plus VBC plus VCN. Okay, as you can see, do you know the voltage across a wire? What's the value of the voltage across any wire?
The voltage across any wire?
Usually, if you measure the voltage across a wire, let's take this voltmeter and check the voltage across any wire. The value will be 0 always and always, okay?
Oh yeah, okay.
So here the PA and CN, they are connecting wires. So this one is 0, and CN is also 0 volts. Is that clear?
Yeah.
So the remaining part will be VPN equal VAB plus VBC.
Okay.
So okay, let me change the color. VPN equals VAB plus VBC.
Okay.
If we want to check what's Kirchhoff's voltage law, the main law of this guy, his name is Gustav Kirchhoff. We can just take all these values to the left side. So we can just write it like this. VP and keep it on the same position, minus bring VAB to itself to the same side, and minus VBC also. So it's equal to 0. If we just place the names in an exchanged form, it will change from negative to positive. Let me write it here, the note. So if I write VAB, It's the negative of VBA. Is that clear? So
Oh,
here,
so we can't write it as positive VAB?
yes, that's great. So that's what I'm going to do right now at the moment. Okay, so if VPN is going to stay the same here, plus VBA plus VCB equals to 0. If we take a look at the circuit, we started from point P to point N. Can you
Okay.
just, you are following me at the circuit?
Yeah.
Okay, so we started from P to N, then from B to A, this one, BA, then from C to B, we can exchange the names. So we can just write it like this. VPN plus VCB plus VBA. We exchanged the position of both, okay? I placed this one here and this one here. So what I did right now, I started adding the voltages from P to N, then from N to C, we say it's a wire, so 0 volts, then from C to B, then from B to A, and also from A to P, it's a 0 volt. So these two are 0. The remaining parts are the battery with CB and BA. Is that clear? Or you just
No.
face a
Wait,
problem with that?
I'm confused. I used to solve it. I just move, for example, VAB and VBC to the other side.
Yes, yes. I brought them from the right side to the left side. That's what I did first of all.
From the wait, how?
Okay, let me just make it simpler for you. Forget the right side, all of what I wrote here, but I will keep them since we will get the same result after seconds.
Okay.
Okay, let's use the same result here. Do you agree with what I wrote here? VPN equal VPA, AB, BC, CN.
The addition of voltages, yeah.
Yes, that's great. Let me just take VPN to the right side. So it's going to be here 0, here VPA plus VAB plus VBC plus VCN plus, sorry, minus VPN. Do you agree till now?
Yeah.
Let's change VPN into positive sign, so it will be VNP. Is that great?
Oh wait, if you change the
Name.
yeah, the name, you're changing the sign too.
That's great. That's great. Yes, that's what's happening. If we read a battery from positive to negative, it's going to be positive. If we change the name from negative to positive, it's going to be negative.
Okay.
So plus V and P. I changed just the last one. Okay, as you can see, we started from P to A, then A to B. Let me just show it here from A to B, then from B to C, then from C to N, then from N to P. We started from point P and we end up with point P. Can you see that? Kirchhoff's voltage law states that the sum of the voltages across a closed loop or closed circuit will be 0. The sum of the voltages will be 0. But we can conclude that the law of addition of voltages and Kirchhoff's voltage law, they are the same. They are totally similar. But the main difference is the shape of the equation. That's all. But we can start from one equation and reach the other, or start from the other equation and reach the first one. Okay. Okay. If you want to do that from the circuit directly, let's forget the yellow colors here and arrows. Okay. So from the circuit, if I want to apply Kirchhoff's voltage law, we can start from point P on the right side and reach back point B, and that's Kirchhoff's law. So we can say VPA, AB, BC, CN, and NP, the sum of all these voltages will be equal to 0. That's Kirchhoff's voltage low.
Okay.
Okay. Did you get it till now? You find there is a problem with that?
No, from VPA to VNP, I don't see any problem.
Okay, great. So let's use this one. Both of them are the same or similar, but just if we take a note, the value of VCN here, this one, it's a wire, right?
Yeah.
There is another wire. Can you just conclude which one?
PA is a wire.
Perfect. So these are zeros, right?
Yeah.
Okay, if we take a look for the remaining values, you will see that they are the same VPN or VNP, VCB or VBC, and VAB or VBA. Okay, so the yellow formula on the right side or the red formula on the left side, they are the same. We just changed the names, or we changed the position of the values from the left side to the right side. That's it. So we can use any of these. I will just erase the right side since you find that the left one is easier, right?
Yeah.
Do you want me to keep it or erase the right side?
لا عادي, it's fine. I can see both. It's fine.
Fine. Great. Great. Now, if we want to apply the law of, this is the law of voltage represented by Kirchhoff's. If we want to apply the law of currents represented by Kirchhoff's, we are just taking the main ideas before we go deep into exercises, since we can see a lot of exercises, different levels. So I prefer to take the main concepts before we go into that part. Usually, okay, let me write it here. Okay, let's take a branch here and a node. Okay, Kirchhoff's current law states that the sum of the currents entering into a loop will be equal to the sum of the currents leaving a loop or leaving a point in a node or junction. Sometimes they call it Kirchhoff's current law and Kirchhoff's junction rule. So both of them are the same. So here, if you want to apply the law of Kirchhoff's, it will say sum of the currents entering will be equal to the sum of the currents leaving. Okay, I'll call here entering.
Entering a circuit or entering
Entering to a node.
A node, okay.
So can you just choose which currents are entering and which currents are leaving? Can you expect?
Okay, so okay, so I2 is entering the node, I3 is leaving.
I2 is entering, I3 is leaving.
Oh no, wait, hold on. It's
Go on, it's correct.
no, okay, and then I1 is entering and I3 is leaving.
Okay.
I5 is entering. If I4 is connected to it, then I4 is the one that's leaving.
Okay.
And then there is the node, which I don't know what did you call it, but it's
nothing.
I5.
So the node is nothing right now, it's just a name. So we said, let me just make it highlighted. So I2, I1, and I5, they are entering, while I3 and I4, they are leaving. Kirchhoff's current law states that the sum of all the currents entering into a point or a junction will be equal to the sum of all the currents leaving this point or this junction or this node. In other words, they can just write it as the sum of the currents IN equal to 0, sum of all the currents entering and leaving. Since let's provide some values here. so we can understand it a little bit more. Assume that we have such a branch. Okay, can you use just the law of Kirchhoff's related to current to find the current I2?
I2.
Use the same law that we have just used before.
Okay, so it's I, then this is 2A.
Let's write
It's
the
gonna be
formula
5.
first. Repeat,
Five?
repeat. 5. Let's write the
No.
formula first of all.
No, it's not 5.
Can you remember the main formula? It's the sum of the currents entering or entered.
Yeah, equals to this, the ones leaving. So
Okay.
it's gonna be, I2 is gonna be 1.
1. Great. Great. So the entering current is I, and the leaving current is I1 plus I2. And now we can just substitute the values. It will be 3A equals to 2A plus question mark for I2. And now we can see that it's 3 minus 2 equal 1A. Okay, did you get it?
Yeah.
This is the way how we can find that the value of the current using Kirchhoff's current law. Let me just provide you a circuit, a complicated circuit for now, and check if you can distinguish between the parallel and the series parts. Okay. All right, let me call them R1, R2, R3, R4, and R5. Okay, can you tell me which of these are in series and which of these are in parallel?
Okay. So R2 and R3 and R4 are all parallel.
Okay, 2, 3, and 4. Great.
Okay. And then once you find it, 5 and the sum, the parallels that you found, it's gonna be in series with the rest, R5 and R1.
Great, great. So it's easy for you.
Yeah, these are easy. And I find more issues with the superposition,
Okay, great,
Thevenin,
great. Yes,
those.
yes. That's great. We'll try to cover that. Hopefully, during the next lecture, we will go into complicated part. But I provided the first introduction to be sure that what is your level before I go into the hard part directly. I will try to end up with one exercise for today's lecture. And let's check if you know how to solve it or not. Okay. Do you expect if this circuit is a parallel or a series?
Okay, So, and then there are two voltage sources. So, what is this?
Which one? 4 ohms, sorry. 3 resistors.
So this is 4 ohms and the other one is 2 or 9?
Yes, 2 and 3.
2 and 3. Okay, so 2 is in parallel with 3, and then 3 is in parallel with 4.
It's not the case.
Why?
Okay. The main the main connection to be parallel, we must start with a node and end up with the node without any other elements available within the same node. Let me show it on the right side. Let's say that we have here this point A, and let's say we have 2 branches, one for the left or top. Let's say we have here some device and the other one down there. Can you say that these are parallel or series?
Wait,
Okay.
these? They're in parallel because they share 2 points, but yeah,
Perfect.
you're right. A and D
Perfect.
don't share points. I was confused. I
Yes,
thought
that's
I read
it.
it.
So here, if we want to say that this circuit is parallel, there must be nothing between A and D and nothing between D and C. But here there is, yes. So such a circuit, we can say that we can't say that 3 and 4 are in series and they are not in parallel. It's a combined circuit, okay? So not all the circuits can be named as a parallel or as a series. Some might be complicated.
Okay.
Point is point B. Okay, let me just start with the first value. This is 6 volts. And this is 4 volts. All right. Usually they can provide you such a circuit that they can ask you to find the current in each of these branches. They must provide you with the direction, since we can't expect the direction directly. Unless if it's somehow easy.
No, actually, I think you have to do it yourself.
Not always, not always. Sometimes you can choose it as a random and the results will tell you if it's negative, then it's going to be in the opposite direction. If it's positive, yes, you can say that it's on the same directions. Sometimes they can provide you with the sign of the current if it's totally complicated.
No, what I meant, they don't really provide. You
Oh,
have to do it
really?
yourself.
Always and always?
Yeah.
Okay, so what you can do always and always, you can just choose any random direction and the results of each of these 3 currents, if it's negative, then you can expect that this current is in the opposite direction. That's all. So let's assume that the current IAB is from B to A. If we get a result for I equal -2 ampere, then we can say that the direction is in the opposite, not with the same sense that I have taken. Is that clear?
Yeah.
Yeah, don't worry. Concerning the circuits and brand and all these complicated parts, I have studied electronics, physics, option electronics in the Lebanese University, and I've studied engineering, mechanical engineering, 2 subjects, and we covered mostly all of the what we can expect in that part. We'll try to start with the first loop. So usually we can take loop. We'll start, this circuit can be named as an easy one. We will take loop number 1, and then we can move to loop number 2. Okay. How can we apply the law of addition of voltages across the first one?
Law of addition.
Yes. Loop number 1.
So
we start from the battery usually.
yeah.
So let's say UAD or UDA.
Okay, so VAD.
Okay, VAD
is equal to, hold on. So it's equal to VAB.
Great.
Plus VBD.
Perfect. Great. Now the next step, VAD, we can substitute the value of it. It's 6, right?
Yeah, 6.
Can we write it
And-
minus 6 or no, it's 6?
No, it's V8. No, it's 6.
6. We started from the positive to the negative.
Yeah.
What about VAB? Can we expect the value of it?
I mean, we don't have the current,
Let's write it as an expression.
so it's gonna be لحظة. So it's gonna be دقيقة. V is equal to I times R.
Great.
So I can write it as I
Mhm.
2 ohms.
Great. So it's I times 2 or 2I. Okay.
So I. Okay, and then the
VBD plus
3 IBD.
3IBD. Great. Now, if we apply Kirchhoff's law here, we can just take them, all of them, to the left side. And it will be 6 minus 2IAB minus 3IDB, sorry, BD. Equals to 0. Do you agree?
Wait, let me just try. Yeah.
Okay, great. So that's equation number 1. And now we'll move to equation number 2 from the loop, from the second loop. 2.
Mhm.
Can you tell me how can we start with the law of voltage in this loop? Do we write VDC or VCD?
We can do it as VDC.
Great. Equal.
Equals to VDB plus BBC.
Okay, so
Okay.
VDC is 4 or minus 4?
Positive 4, since we start positive.
Great.
Then VDB is gonna be 3 IDB.
IDB.
And then it's gonna be 4 plus 4 IBC.
IBC. Can you find any mistake before I tell you about it? Can you see something? If we just take a look on the left side, starting from equation number 1, you wrote 2 times IAB. Okay,
Yeah.
look here. 2 times IAB is moving on the same direction, so it's positive.
Yeah.
3.
No, this is negative. It's going down.
Which one?
The IBD.
IBD on the right side or the left side? Which formula?
It's on the left, it's negative.
So this one. Yes. Yeah. Okay.
Yeah.
What about this one?
No. This one, I mean IDB.
The right one.
Yeah.
Okay, great. So the left one, it's totally correct. This one, it will be minus or what?
It's gonna be minus.
Minus 3IDB. And the 4, is it correct or we have to change it?
No, 4 is positive.
4 is positive. So it's going to be finally 4 plus 3 IDB minus 4 IBC. Okay. IBC. Okay, is there any other mistakes?
AB is positive, and then
There is one
BC.
mistake. One mistake concerning the names.
Okay, let me look.
Okay, take your time.
DB. C.
With the current, exactly. Check these two currents. Which one is not written correctly?
Okay, there you go. IBD, IDB, IBC.
So
it shouldn't لحظة ما بتشينا it should be CB.
No, it's the current is moving from B to C and it's passing through the correct direction clockwise, so it's correct, IBC. But take a look for this one. It's IDB, although the current is passing from B to D.
The current is passing from B to D.
Yes. Can you see that?
Why is it passing from B to D? Because we moved from the positive side.
Oh, no, this branch, let me just highlight it.
Okay.
In this branch, the current is just moving from B to D by the sense that we have chosen. So it's not going to change the direction of the current if we changed or if we jumped from loop number 1 to loop number 2. It's going to be the same direction. Here
Because
you wrote,
don't we
it.
follow the loop?
I follow the loop for the voltage, yes, but for the current, no, we keep the current as it is, okay? So once you say UDB, it's correct. Once you use the current, you use the current that you have stated initially.
Oh, okay.
Fine. Now we have two equations, right? But how many unknowns do we have here? How many unknowns do we have here?
We don't know two values here.
Two values, I BD and I BC.
Yeah.
That's what we can see. But what about the main current I?
We know
look on the circuit. This is IBC. We don't have the value of this current, right?
No.
And we don't have the value of this current IBD, right?
Yeah.
And we don't have the value of this current IAB, right?
Yeah.
So we have three unknowns. The unknowns are the currents only. AB, I, BC, and I, BD.
Okay, yeah.
So three unknowns. How many equations? Sorry. How many equations do we need for three unknowns?
Three equations?
Three equations. So can we choose or can we create another equation, the final equation? So here we have two equations, equation number 1 and equation number 2. We need one more.
I have a question. Can't
Tell
we,
me.
okay, I don't know if we could do this, but can't we find the current through the entire circuit?
Mhm.
And
Can
then
you,
find,
perfect. Can you tell me which current is the total current or the main current here? Is it IAB, is it IBC, or is it IDB? BD, sorry.
okay, that's the problem.
Tell me.
They're not, I'm considering them two different circuits. We're supposed to consider them their entire circuit?
Yes, it's one circuit. But we are just creating or finding the equations for each one alone. But it's going to be one circuit.
So it's no way it's gonna be IAB or IBD because
it's not IBD and not IBC, but it's IAB. How can I know that IAB is the main current? Do you know? Just take a look on the circuit here.
Okay.
If you apply the law of Kirchhoff's current law, it says the current entering equals to the currents leaving.
Yeah.
So the current entering is which one?
Entering here and it's entering BD and it's entering BC. It's the same.
The currents leaving are IBD and IBC. I'm talking about junction B, okay? This is the junction that I'm talking about. So at this junction or at this node, the current entering is IAB only. The currents leaving are IBC and IBD. These two currents are leaving. So the main current is IAB.
Yeah.
So
they're equal to IAB. The sum of them is equal to IAB.
Perfect. So the third equation will be IAB equals to IBD plus IBC. So right now there are three equations, three unknowns. Or do you expect that these equations, it's hard to solve them or it's not hard?
No, I don't really have a hard time solving equations. That's okay, now I have to find IAB.
And we
know that the resistor value is 2.
Which is the easiest method to start solving such three equations? Do you have an expectation how to find it? There is one method, which is the easiest method. Usually, this equation, the third one, we have three unknowns: AB, BD, and BC, right?
Yeah.
In each of these two equations, we have only two unknowns. Look here, IAB, IBD, here IBD, and IBC.
Yeah.
So in each of these two equations, we have only two unknowns. And the last one here, we have three unknowns. The easiest way we can do it usually, we can just use the equation number 3 to substitute the unknowns of the other two equations. And we keep only one unknown. How can I do that? Let's take a look directly in a simple way. If we just try to substitute, this is here IBD and here IBD, okay?
Yeah.
And here we have IBD. So what I can do, I can just take IBC from this equation number 2 and substitute it here. And the answer will be in terms of IBD. Is that right?
Yeah.
And the same for this equation, I can take IAB and substitute here. And it will be in terms of IBD. And then we can find IBD in the first side. Once we found IBD, we can go to equation number 2 and we can find IBC. Since this equation, we have two unknowns only. One of them is known right now. Is that right?
Yeah.
So in the right equation, equation number 2, we have all the unknowns are solved. And concerning equation number 1, since we have IBD, we can substitute it and we can find IAB. Is that right?
Yeah.
So that's how we can solve such an equation. Okay, how did you find the lecture today? Is it hard or is it okay?
No, it's good. It wasn't
good.
hard.
Okay, great. Concerning the next time, if you find that in this way it's going to be okay, you are finding that it's easy, then we can move to the next lecture and we can start with the more complicated parts concerning networks theorem, Thevenin's, etc., superposition, and we can move directly into that part in the second lecture. If you want something else to explain for you, just inform me before the lecture. So if you have a title, you want me to explain it, inform me about it so that I can prepare something for that, okay?
Okay, but can we cover the tutorials? Because usually our exam questions are
the last file that you have sent me. The exams are close to that.
Yeah, exactly.
Great. I can prepare them and we can start with them during the next time.
Okay.
Yes, no problem at all.
And I wanted to know, do you teach optics?
Well, here in Lebanon, I'm just teaching in more than 3 locations, and I cover optics, but there is a lot of difference between one part or one school or one university and another. So if you want, send me the part that you want or you are asking about, and I can check it. If it's within the same subject that I have studied, then I can do that, yes. If it's away, I can tell you before, okay?
Yeah, no, because I'm supposed to take it next semester, so I'm just checking.
Okay, is it the optics that you are talking about? Is it concerning lenses or no? It's superposition and interference. Do you know the titles?
No, it's lenses, I think.
Oh, fine.
It's gonna be just like the intro, not something too deep.
Okay, yes, we covered this here.
Yeah, because it's not my major, so I'm just taking.
What's your major that you are studying right now?
I'm mathematics for data science. So I'm data science.
Oh, it's mathematics for data science, and you take all these circuits?
Yeah, because we're in foundation. Our first year is foundation.
Okay.
So they are physics students. So we have to cover what they take.
Fine. I got your point.
So
good luck, and hopefully see you during the next lecture. We'll try to specify the time soon. Okay.
Yeah.
Okay. Good luck. I will try to save the recording, and I will upload and send you the link. It's easier than sending you the video. Okay.
Yeah. All right.
Fine.
Thank you.
Have a nice time.
Thank you.
Bye.